here today. This wonderful program that's being presented to us today from the Westboro Senior Center supporters. And please make sure that if you're not a member, it's $5 a year. They may call on you to bake something or help out with something, but they're a great organization. They do a lot for us. This past summer, they paid for all our entertainment on Tuesday nights. They paid for our bus to go to Wright's Farm, and they bought our brand new pool table so that now the folks here can participate in the Inter-Senior Center Tournament Program. So anyway, I think that's what it's called. Anyway, so of course this gentleman is obviously, he walked in and I said, "You have no idea who I am, but I know who you are." And in my house, when you said, "Well, what did Harvey say?" You believed it, because if he said it was going to rain, it rained. If he said it was going to be sunny, it was sunny. And if he said it was going to snow, it snowed. And some of us were a little more pessimistic about New England weather. We wore our our rain hats, our sunglasses, and our boots all in the same day. So anyway, without further ado, I'd like to, let's keep cutting out. I would like to introduce to you Mr. Harvey Leonard.
Now, anyway, first of all, it's great to be here. What a lovely senior center this is, and thank all of you for coming. And I can't believe there actually were more people, and so we're sold out. So that's pretty cool. Except for the people that I guess have been turned away because we can't fit more people. But anyway, we'll see how it goes. But I'm very happy all of you are here. It's great, and. I have to say a few things before I start. I'm going to start by embarrassing a few people. That's always a good way to start. Take the pressure off me and embarrass some others. So I see so many lovely, wonderful people here in this nice crowd. And there are some people that I also have some personal or professional relationships with. So I just want to recognize a few of them. First of all, my wife Lorraine and I are blessed to have two wonderful daughters. Two terrific either son-in-laws or sons-in-law, whatever is correct. Sons-in-law, okay. And 5 marvelous grandchildren. So one of our son-in-laws is local up here, where our daughter is local. And he's a great guy. And of course you're gonna say, well, of course you're gonna say that. No, he's really a great guy. But it's not an accident, because he has wonderful parents who are here today. Claudia and Phil Felberg. All right, so thank you for being here. And I think a few others of you are here because of Claudia and Phil probably telling you about this and encouraging you to come, so that's great. Now, I actually saw somebody already today that I last saw more than half of a century ago, okay? And it's a person who I guarantee knows more about the subject matter I'm going to talk about than I do. Because we were in graduate school together at NYU in the School of Engineering and Science, and his name is Mark Kramer. So Mark, please, I want to recognize you. Mark, awesome, incredible meteorologist, environmental scientist, and a lot smarter than I am. So now that we're on the topic of a lot smarter than I am, there's at least one more person I want to recognize, and he, for many years, was the meteorologist in charge of the National Weather Service here in the Boston area. He's now retired, but he's not really retired, because now he's heading up the board of directors for the Blue Hill Weather Observatory, one of the great resources in our region. So I want to recognize Bob Thompson. Bob, could you please? Thank you so much. And thanks for everything you've done for all of us. And I mean all of us, which means all the meteorologists, all the media outlets, Massachusetts Emergency Management, so on. And of course, everybody here and the public at large. Phenomenal, and thank you so much for being here. And he's another person who I guarantee you knows more than I do, period, but definitely knows more about what I'm going to try to share with you today than I do. So, yes, I'm a meteorologist, so I want to give you a little bit of background about why and how we're talking about climate change. So, I'm a meteorologist. I'm not a climatologist. I'm not technically a climate scientist. that's a different group of people, so that's not the work that I did. But I will say that every year, I did attend regularly conferences that were sponsored by the American Meteorological Society, which is a national organization of professional meteorologists, and happens to be right here in Boston on 45 Beacon Street. Great resource for all the meteorologists and others. So they sponsored these conferences, many conferences on meteorology topics, related topics. And so there was always one on broadcast meteorology. So broadcast meteorologists from all over the country would gather once a year at different locations around the country. And there were many short courses that were offered. Several of them were in climate change. I did attend those to try to become more knowledgeable. So that's kind of where I sit. So as a little background before we get to the actual presentation here, let's try to get a few things, if we can, as best we can, out of the way, because it's very easy to either misinterpret things or somehow the science turns into politics, which is never good for science, but is close to unavoidable these days, in some ways, unfortunately. But, okay, weather. It's a beautiful day today, right? That's our weather. And we all know about a weather forecast. You know, let's consider it tonight, tomorrow, a few days, maybe even a week out. All right, so that's all about weather and weather forecast. And we all know, of course, that our planet revolves around the sun. And the way it does is in such a way that different parts of our planet get heated differentially. So that sets up temperature differences on our planet. The colder air from the north, warmer air to the south, there's often clashing. Everything's trying to achieve a balance. Cold air is trying to come down from the north, warm air is trying to come up from the south. We get these boundaries, we call them fronts. Along that, we get disturbances, low pressure areas, and that's where we get a lot of our precipitation. So this is all part of the weather engine, because when you have temperature differences, simple physics, you have pressure differences directly proportional. And the movement of air from high pressure to low pressure is wind. So that starts the whole thing going, all right? So there is plenty of weather that occurs naturally. There's, let's call it the general circulation of the atmosphere, all driven initially by the differential heating of our planet. And many weather patterns come off of that. So a lot of things that happen are natural. So the question is, when we start introducing the idea of climate change, how do we determine what is just things that happen all the time and what might be something more than that? That is really the question. And in the field, I will say that the last I saw, 97% of climate scientists do believe that man-made global warming due to increased greenhouse gases is real, is already a problem, and will be a bigger problem going forward. But 97% is not 100%. So there are still voices, even in the scientific community, that will say something different. And one of the reasons they have a way to say something different is the reality is, for normal reasons or normal fluctuations, our climate has always been changing. So how can you know for sure that the changes that occur now, okay, are being induced, fueled, or added onto by climate change, increased greenhouse gases? So as I go through the presentation, and Mark Kramer, Bob Thompson, if I get out of line or say something that's really wrong or something, just come up here, take a hold of the mic and say, this guy's wrong, and set everybody straight. Because, you know, again, this is not the Bible. I'm not the ultimate authority on climate change or climate science, okay? Obviously, I've spent my career being a meteorologist and a weather forecaster. So the difference between weather and climate, we talked about weather. That's what's happening now, the weather forecast, and so on. Climate is the average of weather over a longer period of time, okay? So that's different than just the weather we have. And to me, I think it's very important not to overreact or to over-attribute a single weather event. Oh, that's climate change. That was caused by climate change. That's where I think we run into problems and give deniers kind of an avenue to start speaking, okay? So I'm not saying this is correct. This is kind of how I kind of view this, is that I would say, let's take a year ago, and a little over a year ago, Hurricane Ian hitting the west coast of Florida. Now, maybe 3 to 4 days out, it looked like Tampa and St. Pete would be, you know, the really, we would see the core of the storm. Around 24 to 48 hours out, it started to become evident that the worst of it was going to be a little bit farther south, you know, more in the Fort Myers area and Naples and so on. Now, a lot of people say, well, that was so powerful, so strong, you know, that was caused by climate change. I think that's an incorrect statement. I mean, tropical storms and hurricanes are part of weather. They happen. They've happened in the past. They happen now. They'll happen in the future. However, the ocean water temperatures off the coast, the west coast of Florida, were running a good 2 to 3 degrees above average. That's more fuel and energy for the storm. Probably helped the storm be a little bit stronger than it otherwise would have been. And to me, that's a better way to look at things, all right? Certain things are happening, certain types of storms may be a little bit stronger than they otherwise would have been because of climate change. Now, the reason I say that, okay, we know that ocean water temperatures are rising, okay? They're definitely in a trend going up. And I'll be showing you graphics. This is just an introduction to everything. So we know that, all right? Now, we also know there's a warming on the planet, and there's also a lot of extra heat being absorbed by the ocean. So see, ocean water temperatures are going up. Now, that creates more available energy as that extra moisture, warmth. We have to remember that warm air holds more moisture than cold air, okay? So a warmer world is a wetter world by definition, all right? Now, I know some people say, well, wait a second. Okay, so that means some storms are even a little more powerful, okay? Which I would contend may be the case in some situations. So it's almost like, no, climate change didn't cause a specific storm, but perhaps it allowed that storm to maybe be on steroids a little bit, something like that. And the thing is, when you get up into the wind categories that cause damage, it's not a linear relationship, it's more logarithmic, meaning as you add velocity, you're adding a lot more destructive power to the storm. So it really matters if it's a little bit stronger than it otherwise would have been due to climate change. So I think that's a concept, at least that's how I tend to view some of this. It's not as simple as that, obviously. So I wanted you to know that. I also wanted you to know, I think I saw a statistic recently, something like either 50 or 55%, roughly 50% of the population of the United States lives within 55 miles of the ocean. You know, it could be 50-55 or 55-50, I don't remember. So when we talk about what's happening near and along the coast, it's impacting many, many people. We also know that sea level is rising. So I would just say this statement, all right? If we know that ocean water temperatures are running higher than their long-term averages, all right? Sea level has been rising. Just take those two things. Well, just the fact that sea level is rising, when we talk about beach erosion and coastal flooding, even if we get the same exact storm that we otherwise would have had or have had in the past, if sea level is higher to begin with, then you run the risk of, you know, a lower threshold to start coastal flooding and beach erosion. It may be worse, okay, because of that. Now, because of the warmer ocean water temperatures, the storm itself may be a little bit stronger. So there is a second compounding effect. And then if we look at the number of people living near or along the coast compared to decades ago, that's way up. So that's an increased vulnerability. And if we look at the number of structures near and along the coast, that's up. So if you add all those factors together, does that create some reason for concern going forward? I would argue it does. So those are some of the things that I wanted to have as a little bit of a background. And now I'm going to begin the slide presentation. By the way, after we're done, comments, questions, criticisms, anything like that are totally welcome. I am not in a rush, so I'll be here for a while after we finish, and I'll be happy to entertain those. Now, two other things I wanted to tell you that if you want to learn a lot more about climate change, one of the resources, climatecentral.org. They do a lot of work on this. In fact, they create a lot of graphics, informational graphics. They supply them for television stations. All television stations can use them, if they wish, or change them to match the look of their particular, graphical look and things like that. So climatecentral.org, you'll find a lot more information about this. Also NASA, if you start digging through NASA and get into the topic of climate change, you'll find plenty of information there, no question. So the idea of this, and by the way, the graphics for this were actually put together by Climate Central. And we as a station have definitely used some of their graphics at times. And I do have, somewhat limited, but an ongoing relationship, with Channel 5. So we're able to continue to do this. So the idea of this is that the three S's, climate change, is simple, serious, and solvable. Personally, I think the third one, solvable, might be a little bit optimistic. Mitigating the problem, yes. Solving it, it isn't just up to us. You need worldwide cooperation. That's not the easiest thing to do in this day and age, get worldwide cooperation. So, that's the point. But there are things that can and already are starting to be done. So the idea, when we talk about increased greenhouse gases, is that they trap heat in the lower part of the atmosphere. And fossil fuels, the burning of coal, oil, natural gas, puts extra, or at least additional, carbon dioxide into the atmosphere. And one of the problems, and it's a greenhouse gas, meaning it tends to trap heat. So the normal thing is, a day like today, it's sunny, temperature goes up during the day, and then at night, a lot of the heat from the day goes back out to space. And that still happens. But not all of it can go back out to space. If there's a lot of greenhouse gases up there, then it tends to trap the heat and create the nights not as cool as they otherwise might have been. And actually, we have seen a bigger change in warming at night has been greater than the warming during the day. These are all averages around the globe. Yes, both are occurring, but the nights, I've seen a bigger difference, which does make some sense with the greenhouse effect. Now, it's interesting because they're just trace gases in the atmosphere, but water, they're all important. But carbon dioxide is what we're going to focus on. Water vapor is obviously very important as well. And I mentioned how a warmer world is a wetter world. We'll see in an upcoming graphic. I think for every degree that the average temperature goes up, that's 4% more water vapor that's available. And then also, I'm not as up on this as I should, but not too long ago there was a volcano, I forget the name, but I believe it emanated from below the ocean surface, which means a lot of additional water vapor is now in the atmosphere, maybe for the next 1 to 3 years or something. So that's even more moisture that's available when there are storms and things like that. So that's the thing. And one of the reasons why I say solvable, carbon dioxide stays around for a long time. It doesn't go away quickly. So the reality is, the first thing that we hope to do, realistically, is slow the rate of warming. It's going to have to be down the road some, hopefully, if the world cooperates, that will start going the other way. So those are a few things to keep in mind. So as I mentioned, not real complicated. We know the sun reaches the earth. A lot of it's absorbed, some of it's reflected back. We know that. And It's the greenhouse gases, that tend to trap that heat, as I said. So that's the thing. Now, this was talked about a long time ago. So, yes, the Industrial Revolution occurred after this, but, and again, there are times as I go through this where, I'm sure you're already saying, well, Harvey obviously buys in on climate change. And there are other times when you might say, wait a minute, is he like punching holes in this? And then there are other times you might say, what does he really think? And here's one of the things, that I think is always important to know with science. Science evolves over time. That means we could always learn something tomorrow that we don't know today that to some extent could alter an argument, or the argument in this case. So it's always important to keep an open mind and always try to learn more as we go along. Well, anyway, so this was thought, way back in the 1800s. But I also remember, kind of when I started out in my broadcast meteorology career, the television part, which was 1974 in Providence, Rhode Island, I remember Time magazine, one of their issues on the cover said, "The Ice Age cometh." Think about that. So there was concern, and actually you'll see in some future graphics, there was a little bit of a cooling that went on in the 60s and early 70s. So the concern was, about a possible ice age. So that's how some naysayers say, oh yeah, well, 40, 50 years ago you're talking about an ice age, now you're talking about this, then you'll be talking about an ice age, because it is true that our climate has always been changing for natural means. There are many different type of weather patterns that we have. There are sunspot cycles, the way the Earth orbits the sun. I mean, there's so many different factors that can have an effect, but the climate scientists are very strong in claiming they're looking at all of those other factors, but they cannot explain the steady trend upward in recent decades without talking about increased greenhouse gases. So that's what the researchers, for the most part, say. And now, there's also, I have to tell you, in academia, there's sometimes scientists, meteorologists that have different points of view and write up papers, but maybe they don't get published. Now, they probably don't get published because it's not deemed that the research they did, the methods they did are accurate or correct or whatever. Some would say they can't get published because there's a bias against them getting their point of view across. Could there be some of that? There could. I would have to contend, though, I think you'd have to think there's a worldwide academic conspiracy going on if you think the truth is like being hidden from us or something like that, okay? The weight of the evidence certainly points, from what I can see, from what I read, hear, see, and so on, in the direction that you're hearing about. So the burning of fossil fuels puts carbon dioxide into the atmosphere, and so by burning coal, oil, and natural gas, we're warming the planet. Okay, so this is a graph that shows what's been happening with carbon dioxide. Notice it's been going up, the amount in the atmosphere, parts per million. But notice how it's going up more sharply, okay, in recent decades. So you say, okay, what's been going on with the temperature during recent decades? So we look at that, and you might say at first glance, well, that's not the same as the carbon dioxide. Look at that, it's up, it's down, it's up, it's down, it's up, it's down. Yeah, because there's many factors, obviously, that affect that. But if you average that, then you do see a correlation, okay? The temperature, in spite of the ups and downs, are going up. Now, here's another way I want to explain that to you. So this past year, on Saturday, February 4th, Boston, it was very windy, and the temperature dropped to 10 below zero. The coldest temperature since 1957. And some people that I ran across, hey Harvey, where's global warming when you really need it? Yeah, I understand, that's a natural reaction. How could there really be climate change? How could we be warming and we get the coldest temperature since 1957? All right? Again, I don't think we should overreact to one day in one location or one area of the globe. Now that was February 4th of this year. February 5th was Sunday. I remember it well because I actually gave a presentation, because we were a day before the 45-year anniversary of the blizzard of '78, and I gave a presentation on that storm at the James Library in Norwell, okay? It was at 1 o'clock in the afternoon. Of course, it wasn't outside. I mean, it was 10 below zero the day before, but it was 52 degrees and sunny. That's pretty remarkable in itself. Cold air is heavier than warm air. It's harder to dislodge. So to have a flip-flop like that in one day. So yes, that was a wicked cold, but extremely brief outbreak. And of course, if we look at the winter as a whole, which is much more important, it was warmer than average, okay? So that's what's always important to keep in mind. Another thing, I wonder, if you think back maybe to some of your younger years, as best as your memory is, you know, everybody would talk about an old-fashioned New England winter. You know, it starts to get pretty chilly in the fall, and maybe late November, beginning of December, you might get a snowfall, and it stays pretty consistently cold, and the nights are long, the days are short. Some of that snow and ice can be around into March. It's been a long time since that has happened. Yes, this coming winter will be 9 years ago when we had the incredible snow blitz from late January into March. But even that wasn't a full winter of that. In fact, prior to that, prior to January 23rd of that year, that winter season, Boston only had 5.5 inches of snow. And we consider meteorological winter to be December, January, and February, because those are the 3 coldest months on average. So we were more than halfway through. So yes, it was very intense, and certainly we do get sometimes still, not last winter, very intense winter periods within the winter, but it seems that getting a long, continuous winter is getting harder to come by, all right? But remember, that's on average. So another way to look at this, if climate change can be real, and the following happens. Winters are going to average warmer as we go forward. But it does not mean that every winter will be warmer than average. What it means is it's more likely that more of the winters in the future are going to be above average than those that are going to be below average. That's the way you have to look at the idea of climate change, okay? All right, so we look ahead. This is just an example in Oklahoma City showing the warming once we got into the 70s. So it's pretty pronounced, pretty consistent, if anything, maybe even accelerating, okay? So that's just one location. This is looking at Philadelphia, and remember I mentioned in the 60s and early 70s there was a bit of a cooling. You see a little dip there on the left-hand part. But since then, yes, ups and downs, but overall, clearly moving up now for about, a half a century. So remember I mentioned that, even if the world does a good job of moving to clean, renewable sources of energy reasonably quickly, even if that happened initially, because, carbon dioxide stays up there so long, we're probably going to be slowing the rate of warming. Not so quick to reverse it. That's the feeling here, showing you what could happen on our current path and what could happen if we make significant emission cuts and introduce clean, renewable sources of energy more and more. So that's the idea behind it, all right? Now, why is it a real concern? Why is it serious? I know a lot of people saying, I like it more when it's warm than when it's cold. What's so bad about that? Okay, yeah, I get that. I understand that. But here's the reason. Because of extremes. As I mentioned, a warmer world is a wetter world by definition, okay? Because warm air holds more moisture than cold air. So having higher amounts of precipitation, more frequent high-end precipitation events, it's always the extremes that causes the problem, the damage, the flooding, things like that, okay? But then you say, well, wait a minute, but I also hear that there can be more droughts. What's going on? You can't have it both ways. Well, maybe you really can. For one thing, if you're in a warmer world, when you get into a sunny and hot pattern, it's even hotter than it used to be. That means you're able to the sun is able to start taking the moisture out of the soil even more quickly. And so we're even seeing things like that, even in the West, where we know the droughts are getting worse and lengthier and more severe forest fire season, okay? Yet, the West Coast had amazing, massively heavy precipitation events this past winter season, cold season. But because they can also get into those intense, warm, hot, dry patterns, can start taking all that moisture out of the soil. So you can have droughts in some areas, heavy precipitation events in another. Two types of extremes, both are costly, expensive, can be dangerous, can cost lives, and all those things. So that's the idea. So obviously rising seas, more extremes, and all that. So that's what it kind of leads to. Now, this is just showing you a change, a little short animation, showing that as we're going forward, again, you're seeing more heat, more extreme heat, and not as much cold. Not zero cold. So that's what I'm saying. It doesn't mean, we have climate change, so we'll never be cold again. No, that's not what it means. But again, maybe it's going to be a harder time sustaining the cold through a winter season or having many colder than average seasons. That's the suggestion behind what seems to be taking place. Now, this is showing you, this is interesting, this is showing you records. The purple color, record cold temperatures. The orangish color are record high temperatures. So if you look around the 60s and into the 70s, notice the purple is higher than the orange. There actually were more record cold temperatures than record warm temperatures, okay? But if you look at the last 5 decades, the record high temperatures are beating the record low temperatures seemingly by a widening margin over time, all right? Now again, those who believe, normal climatic variation trumps everything. I didn't mean to use that word. Seriously, that wasn't not meant. For those who, are saying that, they're saying, well, look, it was cooler than average in the 60s and 70s, so we've had 50 years of warming, we'll probably go back the other way, And some of that may happen through normal climatic variation, but it's also going to have to deal with the increased warming from greenhouse gases is still mixed into the equation, all right? So this is what I'm trying to say. It's like, imagine if we weren't having increased greenhouse gases and we were going to go through a decade where, let's say, the world was going to be 2 degrees above average, and then the next decade 2 degrees below average. So you put the 2 decades together and it's average, all right? But what may happen is, instead of being 2 degrees above average, that first decade, it could be 4 degrees above average. In the second decade, due to normal things, it turns cooler, but we wind up at average. So in other words, we go from above average, and even in the cool periods, only to average, then way back up to above average. So that's the thing. Anybody can make the argument when we eventually do turn somewhat cooler over a particular decade. You see, it's all reversing, it's all turning around. But that's too short an answer to the question, most likely, okay? But you can see it's complicated, it's tricky, because the general circulation of the atmosphere creates so many different kinds of patterns in and of itself. And that still goes on. That will always be the main driving force of our weather. Okay, the increased greenhouse gases, as I said, is an additional component, and an important one, into the already existing complex general circulation of the atmosphere. So that's where we sit. Now, snowfall patterns can be changing regionally and seasonally. So what we've noticed is the greatest amount of warming has been in the higher latitudes, in the polar regions, all right? And so the normal thing is in the winter, there's obviously a cold pool of air that sits close to the North Pole, and it's called the polar vortex. And you're saying, oh yes, yeah, the polar vortex was discovered, I remember about 5 or 10 years ago, they started using it in the media. No, it's always been around, okay? But some media outlet decided that's a catchy phrase. And so they started to use it as if, oh my gosh, now we get polar vortexes, okay? So it's very difficult for you, person, to be able to either have enough knowledge or to be able to filter out sometimes what's being real, what's not, what's being exaggerated, what's not being put in proper context, and things like that. But in any event, there's no question that the overall warming, particularly in higher latitudes, it's causing these polar vortexes to sometimes stretch or elongate. That gets into the shape of the jet stream. And it can allow things, normally weather moves from west to east, right? Jet stream like this. More dips and bulges, ridges and troughs. So you can get more extremes on both sides. And actually, this is interesting. So when we talk about, if you see on a weather forecast on a given day, oh, the high today was 60, the low was 50, the average is 55, and for this date, that's 3 degrees above normal. Okay, where did they get, or above average, where did they get that from? Well, we consider the average temperature for any date to be based on the most recent 30-year period, all right? And every decade that gets advanced. So for example, right now, everything gets compared to what the averages were between 1990 and 2020. Once we get to 2030, everything going forward will be compared to the averages between 2000 and 2030. So when we made the change from 1980 to 2010 to 1990 to 2020, wait till you hear this. Do you know what happened to Boston's snowfall? Went up from roughly 44 inches to 48 inches, and you're saying, wait a minute, that kind of blows up the whole argument of climate change. Not really. First of all, the average temperature went up. And now you're saying, okay, but that doesn't make any sense, because if it's getting warmer, there should be less snow. But because of the configuration of the jet stream, having some changes and different bulges and dips, it created more opportunities for us to get a setup of some blockbuster snowstorms. Now, even if that were to continue as we go out in time, if nothing else changes other than a continuation of increased greenhouse gases and overall average warming, some of those snowstorms will eventually become rainstorms. And then the averages, even there, will go down, if that's what is to happen going forward. So there's a lot of things, and a lot of things can be done with numbers. We all know that, and data and statistics and things like that. So there you see it though. But you see it says globally less snow overall, shorter snow seasons, all right? But locally, and we have had that in the Boston area, the potential for bigger snow events in snowy areas. Now, what will this winter be like? I don't have any answer to that. But I do know that one of our cycles that we talk about, when we talk about ocean water temperatures off in the eastern equatorial, down near the equator, like off the coast of Peru, when it cycles warm, we call that El Nino. When it cycles cold, we call it La Nina. Well, now it's an El Nino, which generally means a warmer pattern that could have been part of the reason why the summer was so hot or had so many record high temperatures in the southwest, southern, and southeast United States. We had a very wet summer here. Our temperatures were about average, and we were way below average in the number of 90-degree days. Because if you're going to have so much cloudiness and so much precipitation, you can't be as hot. But we were plenty wet and plenty humid, okay? But what you see sometimes when the news, especially the national news now, which does a lot on weather, they never used to decades ago, but now you see a lot of weather on the national news, and a lot of times what you're seeing is wherever the worst weather is in that given day, that's what you're going to be shown. But what does that lead you to believe? It leads you to believe that, oh my God, every day another part of the country, Armageddon. Okay? But that's being shown to you without context. Now I will say, when they then flip to the meteorologists to talk about what's going to happen around the country in the future, they're excellent. And there is none of that. They're just trying to describe what's probably going to happen. But in describing the weather that just did happen, when news is doing it, they're going to show you the most dramatic video that they can find. It catches your attention, all right? But it can be deceiving. In the days of Walter Cronkite delivering the news, not all of you can remember Walter. How many of you can? Okay, yes, I'm definitely at a senior center, okay. That proves it. All right. By the way, I used to really enjoy Walter Cronkite. In fact, I remember his sign-off once. I think it went something like this. That's the way it is, Friday, December 13th, 1964. This is Walter Cronkite, CBS News, New York. Good night. Anyway, okay, so that's the extent of my impersonations. But what I personally thought, and how you felt, I thought he was very, very credible. I had no idea how he personally felt about any of the issues. I didn't want to know. I just wanted to be presented the information. I'm sure a lot of you feel the same way. So in any event, getting back to this, so that's the thing. So right now it seems like, yes, we can get intense winter periods within a winter, but it seems pretty difficult, probably going to be rather infrequent to have long, continuous, harsh winters. So also what's happening is, this is good, what's been happening on average, it's good for the growing season, because our first frost, on average, is happening a little bit later in the year, and the last frost or freeze is happening a little bit earlier in the following year. So that tends to lengthen the growing season, okay? However, remember, you're gonna say, that doesn't mean it works every single year. It means more often than not, as we go out in the future, that's the way it will be. But it doesn't mean it will always be that way. Climate is the average over a long period of time. All right, so this is just giving you an example of glaciers and what's going on. We know that many of them, are shrinking and melting. This past summer, my wife Lorraine and I had a chance to take a really wonderful vacation to the Canadian Rockies, and we get to walk on a glacier on the Columbia Fields in Jasper. Unbelievable, but they are shrinking up there as well. So we've seen that. Now this is very interesting that 93% of the excrete is actually going into the oceans. All right? So think about that. So here you're looking at the change in sea surface temperature since 1901. And of course, you notice a lot of bright, warm colors because it's been warming in most places. There are a few places where it's cooling, like maybe off of Greenland, melting ice, things like that. But for the most part, we're seeing, a warming. And this is pretty alarming because the sea level rise, which you can see cycles up and down, but not like this. That's pretty extreme. Okay, so another concern is that, higher tides, more flooding, more coastal flooding. So this is showing you, the number of coastal floods. And again, you see plenty of variation in that purple line, up and down, up and down, up and down, up and down, up and down. But when you take the average, it's going up. That's the point. I'm going to jump to this. I think we mentioned this, that for every degree increase in the average temperature, a 4% increase in water vapor. All right, so that leads to heavier precipitation events. And if we look at the period from 1958 to 2016, we're seeing that actually all across the country, most pronounced around here. And I think we've seen that. I mean, we've seen many, many heavy precipitation events. I mean, I remember in the, I talk about decades now, in the earlier decades of my career, I mean, if we got an inch of precipitation out of a storm, that was considered a lot. And now, I mean, we get events, I mean, we all know the horrendous flood that occurred in Leominster. I mean, that's just unbelievable, like about 10 inches of rain in a couple of hours. That's a quarter of a year's worth coming in a couple of hours, all right? But warmer atmosphere, warm air holds more moisture, heavy precipitation events, and we know we're in an area where there are battle zones fought a lot between the cold air and the warm air and the storms. We're at that latitude. So it makes sense that we would be an area that experiences a good deal of that. This is like rain on the wettest day each year, like how much rain got produced on the wettest. And you see a lot of variation. This is for Houston. You see a lot of variation, but again, the average is going up. Now, that huge spike up, all right, several years ago, Tropical Storm Harvey, dumping like 40 to 50 inches of rain in Houston. Okay, a little aside on this, not that it's important because it isn't. What's important is the horrendous floods that they experienced, but I wasn't actually on the air. This is before I retired. I wasn't on the air, so it prompted some emails. Some emails went to the station, like the station management. Are you not allowing Harvey on the air because you think we're going to associate him with what's going on down there? But then there were other emails to me. Are you afraid to come on the air? Because now neither was true. I happened to be on vacation. But it's interesting, you know, how people think all the time. When, you know, some people they're used to seeing suddenly aren't there. Especially if what they do is in the news, so to speak. So that was just kind of an interesting thing. But that was the reason for that massive spike. But the idea is even independent of that, it's going up. All right, now hurricanes and climate change. So what do we know? So again, we know warmer ocean water, more available energy for the storms. That doesn't in itself form the storms, but once they are forming or formed, that can be an ingredient that helps them become stronger. So once you have that, it means heavier rain, and that means more freshwater flooding. But also a stronger storm means you're going to have a higher storm surge, even worse coastal flooding and beach erosion. Okay? And higher winds, more wind damage to structures. So all three factors that get involved with tropical storms and hurricanes all could potentially be enhanced. As far as I can see, even though we've seen a lot of names, a couple of years ago we went past the alphabet, had to go to the Greek alphabet. Now, it's been active, yes, but there is something called a multi-decadal oscillation that happens to be with hurricanes. And it was thought around 1995 that for about 20 to 30 years we'd be in a more active pattern, which seems to have played out. It's not so much, from what I've seen, from what some of the climate science experts have said, that we'll actually wind up with more storms. It's the idea that you may wind up with more very powerful ones. That's the bigger concern. And by the way, yes, we've been in an active pattern. There's no question about it. But I have to tell you that satellite detection is so good now compared to many decades ago that there are some storms that have a relatively small life that develop, become small tropical storms and then dissipate 2 days later. They get a name, they get into the stats. Decades ago, we wouldn't have known about that one. Okay, so that's a factor. It's not the only factor, but that's the idea. But anyway, so it could be that we'll be coming out of the cycle, perhaps, of a lot of storms, but that still doesn't change the risk. It only takes one, all right? It obviously depends on where the ones that form go. In 1992, Andrew, Homestead, Florida, well, that was late August. Andrew, that means it was the first storm of the season. So you say, gee, it wasn't a very active season. You're going to tell that to the people at Homestead, Florida? It just matters not how many in any specific area, but where they go, how strong they are. The drought index in the western U.S., that seems to be getting worse. All right, playing into the idea of the extremes. More heavy precipitation events, but yet more and frequent and more severe droughts. Obviously, hotter years are going to lead to higher fire risk. And so again, you look plenty of ups and downs, but I think you can see that the average, that's what the white line is going up. All right? So those are the reasons it's serious: rising sea level, more extremes in weather. We haven't talked that much about health, the economy, things like that. So let's just touch base briefly. Again, all of these graphics, you're seeing from the heavy precipitation to occasional, major big snowstorms, the flooding, yet the droughts, the fires, and of course tropical storms and hurricanes. The idea, all of these events always occurred, but now they could be with differing frequency and also different and more severity. So that's the thing. This just gets into $1 billion disasters, and of course that's, I presume they're taking into account inflation in this, but again, the idea is if you're going to have more extreme storms, you're going to have more costly storms. All right, so let's just briefly touch upon this. So animals and ecosystems, obviously they adapt to climate as best they can. They go where, the climate is or where the food source is, if they are. So for example, we know the great whites, right? We're seeing many more of them in the last 10 years up at our latitude than we used to. Seeing lots of seals and whatever it is, but we're seeing wherever the food source is, they're going to follow. And so with warmer ocean water temperatures on average, we tend to see that winding up farther north. And I remember, giving this talk to a couple of groups a number of months ago, talking about the fact that, you could theoretically, tropical borne diseases might wind up sneaking a little farther north, like malaria. And sure enough, this year in Texas and Florida, there were some cases. So, things that we think happening in the equatorial regions can start to sneak a little bit farther north as these changes occur. And of course, to our health, worsening air quality. Now, it's interesting because ozone is something that we like to have about 5 to 8 miles up in the atmosphere to block out some of the harmful ultraviolet radiation from the sun. And we occasionally seem to go through cycles of ozone holes up there, which is not a good thing. But down closer to ground level, we don't want it because that's a real irritant, okay? And when you get real hot, humid days with sunshine combining with automobile exhaust, that results the chemical reaction in more ozone. And that can be difficult for, elderly, very young, people with respiratory problems, things like that. Of course, we get increasing risk of insect and foodborne diseases. I think I hope we're almost out of the season, maybe not quite. Triple E and those things that we start to hear about sometimes late in the summer, always a concern. I don't think we heard as much this year, thankfully, than we have in the past. And obviously food and farming. And if these changes, if these climatic changes lead to, changes in weather patterns enough so that areas that used to receive a lot of precipitation with a lot of farmland suddenly go into more frequent dry patterns, well, that obviously affects farming a great deal, and so on. That animals too are subject, of course, to diseases and things. Ways of life. I'm not an expert on the coffee and beer part, but obviously sports. Just think of skiing. Thank goodness for the ability to make snow, because again, that lack of consistent, even in northern New England, we seem to be getting more frequent, brief but warm tropical incursions in the middle of winter. That's horrible for skiing, because that causes all that melting, and then when it turns colder, it's so quick, you have ice, which is the worst to ski on. So I think, some people who have the ways and means financially, say, I'm going to go out to Colorado or Utah. It's better powder out there, than you don't never know what you're going to get here anymore, and stuff. So it's had an effect on that. And this is just giving a brief idea of, just a small additional increase in temperature, and you get more and more effects, from it, from extreme weather, sea level rise, and so on. All right, so this is the part, solvable, which I say, I'm not so sure. I hope it is, over time. As I said, you can need a lot of cooperation. But certainly mitigation can be done, and this is what I mean. The idea that we need to make cuts reasonably fast, because If we continue the way it's going, then the warming just continues pretty much unabated. However, if we make significant cuts in emissions, then the rate of warming slows. That's kind of the nearer term picture of the two possibilities. This is just showing you all the different ways that we wind up with, greenhouse gases through agriculture, commercial, residential, industry, transportation. All right, so I like to tell this little story. All right, so I'm originally from the Bronx, okay? Anybody else from New York? Oh, wow, not bad. I don't know that that's a good thing, but I mean, not bad that there were a good number of people. No, I'm just kidding. Anyway, so I grew up in the Bronx, and by the way, you should know that my family despised the Yankees. So I'm just old enough, so when I was a little boy, and my father especially, big time into sports, we were Brooklyn Dodger fans. We rooted for the underdogs, that was the Brooklyn Dodgers. So when I came to New England in 1974, it wasn't too difficult to become a Red Sox fan when I detested the Yankees to begin with. So that, that part was easy. But when I went to City College of New York for undergraduate school, and I commuted, so that meant walking about 6 blocks, taking a bus, then a train, then walking another half mile, whatever, it's fine. So, one of the most frustrating things, just as you get to the bus stop, bus pulls away. Okay, that's frustrating. What's a lot worse was the thick, black exhaust smoke blasting in your face, okay? So before I retired, I got to do one story on a project that Channel 5 has started called Forecasting Our Future. It's not so much about all the reasons behind climate change as it is about ways to start dealing with it, okay? And so I got to do a story up in Beverly, where they have electric school buses now transporting the kids to and from school. And I got to ride on one of those buses, and it was pretty nice, it was pretty quiet, pretty smooth. And then when I got off, I decided to go back and look at the exhaust system, except there wasn't one. What a difference between that and that thick black exhaust smoke in my face. So I only got to do one story, but it was a meaningful one, certainly for me. It definitely rang home. Okay, so we know about some of the obvious renewable sources of energy, solar energy. In the Southwest, they have the opportunity to get the biggest benefit out of it, but it's still definitely a benefit up here. There's no question about it. In fact, I met somebody who I used to work with back at my old station, Channel 7, not too long ago. He lives on Cape Cod, and he's gone to solar, and he said 1 month I made money because it goes into a bank, and so on. It was pretty interesting. And then somebody else I met said that they went to heat pumps, and they were very happy with that on Cape Cod. So, I mean, things are happening. And of course, there are some incentives that the state offers if you go toward clean, renewable sources of energy, if you're making a change. Wind power, so we're seeing more windmills, a little controversial about environment, birds, things like that. This is just showing you some in California, some of the solar electricity generation and the wind electricity. We don't have to do that too much. Again, I talked a little bit about, electric vehicles and things like that. And finally, this is, actually I'm not going to do it because I wouldn't do that to him, but this would be a perfect time for Bob Thompson to take over because he's not only a great meteorologist, he's like an engineer on top of it. So he would know more about this than I would, but I do know that how things are being built. For example, in the Seaport area, which has been so unbelievably built up in the last 10 or 20 years, but it's a very vulnerable area, to flooding. So I do know that in some cases, if they're using furnaces, they don't put them in the basement. They put them higher up so that if there's flooding, you're not going to lose the furnace. Also, if it's a new structure, they're going to use higher foundations, to try to take account the rising sea level and the risk of, of all of that. And then there's, type of insulation, dynamic glass, and all these things. So, and more electric heating and cooling. But definitely, I would say, hopefully the building codes, are more strict and things like that. But that's for new structures. Existing structures, making changes there, which I guess is called retrofitting, obviously that's a little more complex because you're not starting from scratch, you know, with a new structure. But all these things are ways to mitigate, as I said, solving it, you know, hopefully, God willing, down the road, you know, for the benefit of our kids and grandkids and future generations. But this is where I think we stand right now. So again, it doesn't mean that everything I've said, you know, this is one thing I know that a lot of people have difficulty with. You know, and I understand this. People would like to say, can you just give me an answer to something like yes or no? You know, like they watch you do a weather forecast and they go, you put so many qualifiers in there, you know, and things like that. I remember way back when my wife and I had our first child. And then people started saying to me, hey, you gotta get life insurance. Hey, you have a little child now. And I remember my first reaction was, I think I'd rather bet that I live. Why am I betting the other way? Okay, but of course, responsibly, that's what most of us tend to do. But things like that are all based on statistics. And sometimes, if you don't have all the scientific answers, you can use the best science that you have or know, and then you have to use math, data, statistics, likelihoods. It's in medicine constantly. You know, doctors sometimes with some of the diagnoses they make, and you know, they'll give you 80% chance of this or something like that, you know, and you want to just know, you know, one way or the other, or yes or no. Sometimes you have to make decisions based on statistical likelihoods, not based on certainties. And that's difficult for a lot of people to deal with. And some of that comes into play with climate change. And is how big a concern is it going forward? Lord knows there are many other problems. There are many other issues. A lot of ways that money can be spent by ourselves, by government, and so on. So, you know, but that's what we're dealing with. We're dealing with, you know, the likelihood. And that's what, you know, I've tried to do the best to my ability to share with you today. So I'm going to stop here in terms of this. But I'm happy to take comments and questions about this or anything else. You know, I've noticed a lot of times people want to know more about this. They want to know about other things. It's fine. Anything that I'm capable of answering, I'm happy to do so. And I think I thought we were going to use this. Should I walk around so we can hear the questions? This is the only one we have, right? Okay. All right, well, let's start with some questions and or comments. Oh, yeah, thank you so much. Thank you.